Hey guys, Jake here coming at you with another math lesson today. Today we're going to continue our discussion about limits and continuity from the Elite Guide to AP Calculus AB. If you want to go get yourself a copy of that book, you can scan the QR code in the upper right hand corner of your screen or go check the link in the description below or the pinned comment as well. But today we're going to kind of wrap up our discussion actually about limits and continuity. Tomorrow we're going to start on, or Monday I guess, we'll start on some derivative stuff. So I wanted to do this one problem before we kind of move on to the next general topic. We're going to kind of dive into how to deal with these piecewise functions if you're trying to make sure that they're continuous. This is sort of a common type of problem that you see come up in calculus classes and in AP calculus as well. So wanted to show you an example of how to do one of these problems. So let's go ahead and just dive right into the problem. If f of x is continuous at x equals 3, solve for a, where f of x is this piecewise function, x plus a for x less than 3, 4 for x equals 3, and 3x minus 5 for x greater than 3. So real quick before we dive into this problem, I kind of touched on this in yesterday's video, but just to kind of reiterate, in order for a function to be continuous at a certain point, what we need is the value of that function to be the same as the limit as x approaches that x value at that spot. So basically we would need f of 3 in this case to equal the limit as x approaches 3 of f of x. Well, in this case, since we have a piecewise function, we actually have to break this limit down into the left and right-sided limits. So we need both the left and right-sided limit to equal each other and also to equal f of 3. Well, in this case, we've already kind of been told that this function is continuous. So it's probably okay to assume that basically the right-sided limit and the f of 3 already line up with each other. And the reason I say that is this right-sided limit is just a function of x, right? There's no a for us to solve for within the right-sided part of this piecewise function. So the f of 3, we clearly see, is going to be 4. The right-sided limit, there's nothing we can do to change that function. There's no a that we have to solve for or anything like that. So it's probably safe to assume that our right-sided limit is also going to give us the 4 that we need it to be. You could definitely verify that, but we don't really need to worry about it. Really, what we need to worry about is what this a value is, which is only going to come into play when x is less than 3, which means we're looking at x values slightly smaller than 3, which would be our left-sided limit. So essentially, as long as we make sure that our left-sided limit in this case is 4, we should be good. So we need to figure out what our a needs to be in order to make this left-sided limit be 4. Well, I've kind of touched on one-sided limits in my last few videos, so I'm not going to go into a ton of kind of explanation of the method here. But what we're looking for is the limit as x approaches 3 from the left of f of x. Well, since x is slightly smaller than 3, we know we're going to be using this part of our piecewise function. And then the other thing we can do is kind of use the trick that we've gone over in the last few videos. Instead of saying the limit as x approaches 3 from the left, let's say the limit as h goes to 0 from the right of f of 3 minus h, which will give us the limit as h goes to 0 from the right of 3 minus h plus a, which in this case is actually going to be a fairly easy limit to solve. We can essentially just plug in 0 for h, so that's going to give us 3 minus 0 plus a, which is just 3 plus a, which, like I said, we know needs to equal 4. So we can take 3 plus a and set it equal to 4 and then solve for a. So that just gives us a equals 1. So a equals 1 will make this function continuous at x equals 3. So I hope you found this video helpful. If you did, be sure to hit that thumbs up button, subscribe to the channel, go check out the Elite Guide to AP Calculus AB by scanning that QR code or hitting that link down in the description or the pinned comment below. Like I said, next video we'll start diving into derivatives. So hope to see you there. Thanks and see you next time.